Let's take a look at how we solve geometric application problems. Now, what I'm calling a geometric application problem here is a problem that is based on a sort of geometric type setup. These problems can usually benefit from you drawing a picture, and they're usually really closely aligned with a known geometric formula, such as those for perimeter or area or volume. Okay. Now, the ones that we are going to look at involve perimeter, and the ones that we have in the book and on WebAssign and on the test are all using perimeter of a rectangle or of a triangle. Okay, so the geometric formula that we're going to be using most often is the formula for the perimeter of a rectangle. That formula is perimeter is equal to 2 times the length of the rectangle plus 2 times the width. 2 times the length plus 2 times the width is equal to the perimeter. And these problems usually go something like this. They'll tell you that you've got a rectangle of some type. It may be a picture frame, it may be a field that's been enclosed by fencing, some sort of rectangle, okay? It will give you a relationship usually between the length and the width that you'll write as an expression using L or W as the variable. And then it'll actually give you the perimeter, so you'll have a number to plug in there. Then what you'll do is you'll work the problem solving for the variable that you have, and then using the formula, once you find the width or the length, whichever one you solve for, you'll go back and find the other dimension. We also have some that involve perimeter of a triangle. The perimeter of a triangle is going to be perimeter is equal to side A plus side B plus side C, where those are the 3 sides that make up your triangle. And the problem will be very similar to the ones that involve the rectangle. You'll be given some expression that relates 2 of the sides to another side so that you can get it down to one variable. And then you'll be handed the perimeter, and you'll have to figure out what the 3 sides are based off of that equation. Now, when we work a word problem, what you want to do first is read through the problem very closely. Identify your knowns and your unknowns that you're given. Go back and reread the problem a couple times just to make sure that you understand what it's giving you and what it's asking you. Draw a picture with this type of problem. Label the parts that you can label, and then go into your formula and write your expression down that relates the variables to each other. Then plug that into this formula that you're given here. Solve for the variable, and then finish the problem, being sure that you are completing it by answering all the questions that you're given. All right, so let's take a look at an example. Okay, here's what we have. We are given a rectangle whose length is 4 feet less than twice its width. The perimeter is 292 feet. Find the dimensions of the rectangle. Okay, so here's what we're given. We're told that the perimeter is 292 feet, so we have an actual number to plug in for P. We're also told that the length is 4 feet less than twice the width, so we're going to need to write a little expression for length in terms of width. We will then take the perimeter value in that expression, plug into our perimeter formula that we looked at just a second ago, and then we will solve for what will be width. Once we find width, we'll need to plug back in and get length, because the problem says find the dimensions of the rectangle. That means both the width and the length. Okay, so here's what we're dealing with. We've got a rectangle. Okay, the width of the rectangle, we'll say, is this dimension here. We're going to call the length this dimension. Okay, so we know that the length is 4 feet less than twice its width. Okay, so that means that we would need to take twice the width of the rectangle and then subtract 4 feet from that. Okay, so in expression terms, that's going to look like this: 2 times W, twice the width, minus 4 feet. Okay, and you can go ahead and put the units in here if you want to. Our perimeters in feet also, so all of our length dimensions, or distance dimensions, I guess I should say, since we have length named as one of the variables, are in feet. Okay, so let's set up our formula. Here it is without anything plugged into it. Perimeter is equal to 2 times the length plus 2 times the width. Okay, so here's what we know. Perimeter is 292 feet. And we also have an expression for length, 2w minus 4, 4 less than twice the width. And then we still have that 2w term at the end. So what we've done is we've taken 292, plugged that in for p. Okay, there's a connection right there. Then we've taken the length is equal to 2w minus 4, right here. We've plugged that in for that L. Okay, so this 2 is right here is the same as this 2 right here. And then we can't forget our last term. We don't have anything to plug in for w because we're solving for w. That term's right there. All right, so just like we did on our other little simple linear equations, that are in section 1.1, we need to simplify both sides. We'll do that by the distributive property. So we take the 2 and we distribute the 2 to 2w minus 4. That's going to give me 4w minus 8. Still have the plus 2w right there. Combine like terms. 298 is equal to 6w minus 8. And now start isolating w. We only have the one w term, so I won't have to move that. I'll just leave it where it is. But I will move my 8. I'm going to have to do the opposite here. We'll add 8 to both sides to get that moved. So 192 plus 8 would give me 300. And then to finish up there, you need to divide both sides by 6 to isolate w. So that's going to give you a value of 50 feet for the width. Now go back up and answer the question, am I done? Okay, so let's go back up and look at the question. The last sentence there says, find the dimensions of the rectangle. We'll have one dimension. I have the w. I also need to figure out what L is. Since I know W, I can very easily find L by just plugging back in right here. You could go around the world and plug it back into the perimeter formula, but it's so much easier since we've got this little expression to just plug it back in there. So if W is equal to 50, oops, hang on a second. I can't get rid of it. Okay. Meant to hit the pan button, sorry. Scoot back down here a little bit. So if W is equal to 50 feet, the length is equal to 2W minus 4. So your length is going to be 2 times 50 minus 4 feet. That's 100 minus 4, which is 96. So your length is equal to 96 feet. Now if you want, you can plug those two values back in and just make sure that they make sense for your perimeter of this particular rectangle. You should get 292 for the perimeter if you plug that back in for L and 50 back in for W.